right, so let's take a look at this. I like these notes because there's a lot written on here already that keeps you from having to write it. So, because there's a lot of pictures and graphs and so on, and everybody has a calculator, yes? Because calculator is going to be your friend in Chapter 10. You've got to start getting comfortable with the calculator. Yeah.
Friends.
You can do it without, just more work.
There's a Moodle.
There's a Moodle, and I'm recording what I'm doing now, too. Okay? Yeah. All right, here we go. Shh. So, let's talk about quadratic function. Ax squared plus c and ax squared plus bx plus c. Those are both quadratic functions. We're going to talk about the words you're going to see in this chapter. A quadratic function is a nonlinear function that can be written in standard form. This is standard form. It has 2 as its highest degree, and that's called a quadratic function or equation. Okay? So, what I want you to do right here is kind of draw a y-axis, or excuse me, an x-axis and a y-axis, but make that x-axis kind of low. Okay? X and y-axis. It doesn't matter. Let's go through these definitions. A parabola is a U-shaped graph of a quadratic function. So I want you to kind of draw a semi-neat parabola that goes through the origin and comes back up. Okay, now this is a sketch of y equals x squared. It's just a sketch. I didn't figure out exactly what the points would be, but wouldn't it be easy to get points for this particular parent function, it's called? So, like, let's say that you could just do this in your head. If x is 2, what would y be?
4.
If x was negative 2, what would y be?
4.
4. Careful. Negative 2 times negative 2. Negative 2 times negative 2 is positive 4. 2 times 2 is 4. If x was 6, what would y be?
36.
Okay, you see what I mean? It's kind of an easy function to come up with points in your head if you had to graph it. And what it's called is it's called the parent function. And we're going to be working with the parent function. It's the very basic, most basic quadratic function. Lisa, you need to put that away. Okay, the most basic quadratic function. It doesn't have anything added to it. It's got nothing multiplied to it. It's got nothing in front, nothing added, nothing subtracted. It's just the basic parent function. And we're going to look at what happens when we start multiplying stuff and adding stuff and subtracting stuff. Okay? So that's what this is all about. All right, the next thing we're going to look right here is parent quadratic function, y equals x squared. Vertex is the lowest or highest point on the parabola. Right here is our vertex. It's the lowest point, and it's going to be written as an ordered pair, always. The minimum value is when the parabola opens up, or A is positive, the minimum value is the y-coordinate of the vertex. All right? So, right here, there's A, and that is positive. If A is positive, the parabola opens up. So if A is positive, you're going to see me do this a lot in this chapter. This is a parabola. My arms are a parabola. Okay? My body is the axis of symmetry. If A is positive, the parabola is going to open up. And then, since it's the vertex is the lowest point, it has a minimum. And these are, like I said, I'm just throwing a bunch of words at you. You're going to work with them. You're going to get more comfortable with them as we go. A minimum value. Okay. Let's look back down here at the parent quadratic function is y equals x squared, which is what we sketched here. What is the domain of this function? Meaning what x values could be on this graph? anything, right? Because if you, even though it doesn't look like it, this graph goes forever and it goes slightly out forever. So the x coordinates could be anything. And this is the symbol for all real numbers. Did I show you that before?
It's like a paragraph.
Yeah. You don't have to use that symbol. You can just write all reals or all real numbers. It's up to you.
Oh, really?
Now let's talk about the range of this particular function right here. The y coordinates, if I picked a point anywhere on this graph, the y coordinates would be all what?
Positive and 0.
Greater than or equal to 0, right? The y coordinates would all be greater than or equal to 0, and that's what the range is. The range is about all the y coordinates of any point on that line or that graph. Okay. The vertex is the lowest or the highest point on the parabola. The minimum value. When the parabola opens up, like ours does, and A is positive, the minimum value is the y coordinate of the vertex. And these, again, I'm just throwing words at you. We'll be working with them later. So, and then the maximum value, if the parabola opens down, and the A is negative, when the A is negative, the parabola opens down, the maximum value is the y coordinate of the vertex, and we'll look at those later. Let's look at the axis of symmetry. Sounds like a cool word, doesn't it?
Sounds painful.
Axis of symmetry. It's the line that passes through the vertex and divides the parabola exactly in half. You don't have to use a different color here. I'm just so you can see it better. The axis of symmetry is right here. It's the line that splits the parabola exactly in half. It is for our instances, a vertical line. Mm-hmm.
So will it always be like 0 on the y-axis?
Mm-hmm. So remember when we wrote equations of vertical lines? And this is a vertical line. What would the equation of that line be?
0.
Right on. X equals 0. That's the equation of that line. X equals 0. Okay? Question for you. If the axis of symmetry is x equals 0, what's the x coordinate of the vertex? Parker, 0. It's the same thing, isn't it? All the x coordinates on this line are 0, as is the x coordinate of the vertex. We're going to use that later, so just pointing that out. Okay? So these are the terms, the definitions. Any questions on the words you're going to be using? We'll practice with them, but... Okay. All right, here we go. So let's practice graphing. So we're going to graph y equals ax squared when a, the absolute value of a, is greater than 1. What? Oh, completely dead? Put it on my desk then, please. All right. So let's graph negative 6x squared. Compare the graph with the graph of y equals x squared. Now, remember I told you, you're going to be comparing what happens to the parent function when we multiply it by something. So what you always want to do is graph your parent function on the graph. And this is y equals x squared right here.
Can you like get color and color?
And you can kind of tell because look here, if x is 3, y is 9, isn't it? 3, 9. See that? And then here when x is negative 3, it's also 9. So it's easy to graph that parent function if you just think about it. All right, now, make a table of values for y equals negative 6x squared. If you don't have a calculator at home, most definitely you can just plug in and do the math. Negative 2 times negative 2 is what?
4.
4 times negative 6 is what?
Negative 24.
So when x is negative 2, y is negative 24. Or you can use the calculator. So you go to y equals, go to y equals, clear whatever's there, put in negative 6x squared, just to remind you how to get to the table.
Second graph.
You all know how to get to the table?
Say y equals.
See, it's right up here. That one's dead too. And then you just do this. Oh, look, all the values are there. This is all the fish food, this is all the fish poop.
Gross.
Okay, this is what went in, this is what came out. So when x is negative 1, what is y? When x is 0, what is y? When x is 1? Oh, isn't that interesting? When x is 2? It is a function.
Oops.
It passes the vertical line test.
How's this gonna work? It'd be like just like a.
It's right here. So when we graph those, it looks like this. Okay? So that's that graph right there. Now, it is a function because for every input there is one output. Doesn't matter if they have the same outputs. See, negative 2 has negative 24. Positive 2 has negative 24, and that's fine. And it passes the vertical line test, for those of you that are asking. But let's look at this. Do you remember when we did exponential functions and we multiplied by a number, and what did we say happened to the graph? What was the description? It stretched, didn't it? And when we multiplied by a fraction, what happened to the graph? Shrank. It was a shrink, right? Well, this is the same thing. If this was not negative, if it was just 6x squared, it would be a what? Stretch. It stretches. It makes those y coordinates bigger because you're multiplying by 6 every time, okay, compared to the original function. So then what happens when you add the negative then? No, it reflects. It goes, when you add the negative, all the y coordinates become negative, which causes it to reflect over the x-axis. So when you multiply by the 6, it stretches those y coordinates, makes them bigger, and then you add that negative, it makes them all negative, so it faces down. That's why when a is negative, your parabola is face down. So let's talk about that. This is what you have to do in your homework. You have to compare the graphs of y equals negative 6x squared and y equals x squared. You could say both graphs have the same vertex, 0, 0, and the same axis of symmetry, 0. And you also would say y equals negative 6x squared is a vertical stretch and reflection over the x-axis. A vertical stretch and reflection over the x-axis of y equals x squared.
So we have to write this every single.
So the 6 makes it stretch, the negative makes it reflect. A vertical stretch and reflection over the x-axis of y equals x squared. Yes, Tyler?
Okay, so when, this is kind of random, but for the vertex, when it says the lowest or highest point, so for it, if it was a positive, A or whatever, it would have to be a low point, but if it was flipped, then it would have to be the high point.
Right, yep, and we're going to work with that later. Okay, let's talk about the domain and the range of y equals negative 6x squared. What coordinates could be on this graph? What x coordinates?
Any.
All reals. We could just do all reals. Or you could write out all real numbers. What would the y coordinates be for this particular graph right here?
All negative.
Yeah, they can only be negative. The y coordinates, if you picked any point on here, all the y coordinates would be negative.
And 0.
So all negatives. Yeah, it better would be to say y is less than or equal to 0. That's the best way to write it. Okay. All right, turn page. Just shrink. It's just like it was with the exponential graphs. So we have y equals 2/5 x squared. Compare the graph with the graph of y equals x squared. So again, they drew y equals x squared right here. This is y equals x squared. Why does it look different than the other one? Why does it look different? No, it's still y equals x squared.
Like numbers on there.
Yeah, because the scale is different.
Oh, yeah.
The scale is different on this graph. That's why it looks different. But it's still y equals x squared. All right, so on your calculator, I want you to fill in the table here. If you want to use your calculator, or you can do it by hand, fill in the table with this function right here. So you go to y equals, clear what's there. Now be careful, I always put my fractions in parentheses. Calculator is really smart, and it follows order of operations very particularly. I just think it's a safe bet to put your fractions always in parentheses, because it might multiply it on the bottom first or something like that. Okay, go to the table and fill in your table here. Remember, you can arrow to the values that you need. Now, my kids like to set the table. Some people like to be funny with my calculators and have your table start at like 2,321. You don't have to sit there and arrow. You can change the way the table starts. Does anybody have that funkiness on their calculator? No? Okay.
Wait, question.
Yeah.
Every variation of the y equals x squared, well, like if the x is in an even scale, like -10, -5, 0, 5, 10, will it always mirror at 0?
Only if, I don't want to say only if. Usually only if the axis of symmetry is x equals 0. It will eventually have them where the axis of symmetry is not right on the y-axis, and then the numbers might be different.
Oh.
They should be different, okay? It just depends. They're not always going to look like this. All right, plot the points. Draw a smooth curve through the points, which we already did. Here's the second one. What happened to that second graph? Did it stretch or did it shrink?
Stretch.
The pink one is the second graph.
Stretch.
It didn't stretch. Stretch is when you stretch it up and it pulls up tighter. A shrink is when it does this. Okay, it gets like squattier. Is that a word? Squattier. Okay, so what happened was, compare the graphs of y equals 2/5 x squared and y equals x squared. Both graphs have the same vertex and the same axis of symmetry. However, y equals 2/5 x squared is a vertical shrink of y equals x squared. Because if you multiply all those x values by 2/5 every time, the y values are going to be smaller than the original ones, aren't they? Yeah, they are. Okay, axis of symmetry. I abbreviated.
0.
Where is the axis of symmetry?
X equals 0.
It is x equals 0. I know it's snowing.
It's been off and on.
Crazy, huh?
Makes me mad.
It's
It's well, such a big.
yeah, it's another snow day.
Okay, Alex, do you have a question? Okay, all right, one more little example, and then we'll move on. All right, compare the graphs. 3, we got a couple things happening. It's being multiplied by 3, and we have 1 being subtracted from it. So compare the graph with the graph of y equals x squared. So I'm going to draw y equals x squared. It is this one right here.
I'm gonna write that.
That's y equals x squared. Careful, yeah. Okay. Now I'm going to fill in my table. You don't, again, have to use the calculator. You could do it by hand. It's not that hard. -2 squared is 4, times 3 is 12, minus 1 is 11.
Say what?
Wow.
So I just got those off the calculator. All right, stop. Hold your horses. Take a look. What's the y-intercept?
-1.
Could you have done that without the table? Maybe. Where do you think that might come from? How could I recognize that without the table?
I know this. know this.
How could I recognize that the y-intercept is -1 from my equation? Naomi,
No.
from the -1. Exactly. That's gonna be your y-intercept. Oh, but wait, if I graph that, oh, not only did my graph stretch because of the 3, but what else did it do?
Shrink some.
You could say that. It slid down the y-axis once.
Never my word.
I like some.
Sunk is cool, but what would we use if it went +1?
Fly.
It jumped. It levitated.
So I started with this, y equals x squared. I multiplied by 3, and then I subtracted 1. Okay? So let's use words for that.
Stretch and slid.
So, both graphs open up and have the same axis of symmetry. They have a different vertex. It went from 0, 0 to 0, negative 1.
Your 0, 0 looks like a column.
So it's a vertical stretch and a slide, or a sunk, as Parker would say, down by 1.
Sunk.
I wouldn't care, but I know in the book it doesn't say it, and in the high school they might not say it, and so it's up to you, I guess. But I have a question then. Let's go back. Remember in the beginning I said if it opens up, it's going to have a minimum value, which is this point right here, and it's the y-coordinate of that point. What would the y-coordinate of that point be?
0, negative 1.
The y-coordinate only.
Negative 1.
Negative 1. Okay? So the minimum is y equals negative 1. And we're going to practice more of that in section 10.2. No. Well, yeah, you will, but it's not very many columns.
I'm just saying.
What I want you to do right now is stand up.
Uh-uh.
As soon as you're done writing this, everybody stand up in your place, in your spot. Everybody give me y equals x squared, and don't think I'm too cool for this. Y equals x squared. Give me y equals x squared. Okay, good. So let's look at number 1 there. What's going to happen to your arms if you multiply y equals x squared by negative 8? First it's going to do this, and then it's going to do what?
C.
Right? The negative 8 makes it stretch, or the positive 8 makes it stretch, and the negative makes it flip. You're right. Okay, very good. So let's look at number 2. Start with x squared. Y equals x squared. Multiply by 1 7. Ooh. What's it called?
Shrink.
Slide.
Shrink. Because it makes your y value smaller every time, so it's not going to be as big as y equals x squared. All right, let's go to number 4. Start with x squared, and it became x squared minus 3. Right? Right? Okay, very good. All right, let's look at number 5. This will be the last one. X squared being multiplied by 1/4, and then added 2.
Now we're making fun of it.
Get it? You see what happens?
That's all the
It's a slide up.
It's a levitation.
Okay.
It should be a rise.
A rise, yeah. Okay, so on this page, you just have to do the circled problems, okay? So you'll see. This is your homework right here.